Hi all, this is Yogesh Sharma. I welcome all of you in the AWS Community Day, Bay Area 2020. I hope you all are doing great, staying healthy and safe. So for today's session, my topic would be the intelligent, serverless and scalable real-time data pipeline using Kinesis, Fargate and CloudFormation. So before moving ahead, let me quickly introduce myself. I'm Yogesh Sharma, working as a cloud architect in Tata Consultancy Services. I'm currently having overall of 10 plus years of experience, and since last 5 years, I'm working in AWS Cloud, ML, and DevOps area. I am currently part of AWS Community Builder program, a new program that AWS has recently launched. With respect to the certification wise, I'm currently holding the 3 AWS certifications. I'm also a technical speaker and blogger, and currently running the multicloudwarrior.com. Before moving ahead, let's quickly discuss the agenda. First, I'll show you quickly about the demo architecture that we are going to build in the demo part of our session. Then we'll touch base upon the serverless concept. Why do we need serverless? What is serverless? Things like that. Then we'll quickly see how Kinesis and Fargate can help us to build the real-time data pipeline using the serverless solutions. And after that we'll quickly have a quick demo, and in the end I'll share few of the new trends happening in the real-time streaming data and the container data. Okay, so what is serverless? So basically serverless allows developers and builders to build the application in different languages without thinking about the servers. So there would be the servers running behind the scenes, but developers or builder doesn't need to worry about that. So if we talk about, there would be 4 main characteristics with respect to the serverless. Like first one would be there should be no provisioning or management of the server. The automatic scaling should be automatically available out of the box. Pay for value is like AWS or any cloud provider who is providing the serverless managed services are going to charge you as much as like you're consuming that particular service is. For example, if you have the Kinesis, if you are storing the data inside that at that particular point of time, or if you are storing the data, then only the AWS is going to charge you. Otherwise, you can create it. If you're not going to use it, AWS is not going to charge you. The high availability and scale is in security, 2 main aspects that should be also be the out of box characteristics of the serverless managed solutions. Now let's quickly look at the demo architecture that we're going to build at the demo part. Don't worry about all the services and connection. We'll quickly touch base upon on all of them. But the idea is like we do have a load balancer which will accept the traffic from the external users. Then we should have some kind of producer task that will ingest the data into the Kinesis data stream. Then we'll consume the data, process the data using the consumer task, and all these producer and consumer tasks are basically attached with the auto scalable policy that will do the auto scaling on the basis of particular metric that we'll see in the demo bar. So moving ahead, we'll see the AWS Service portfolio. So if we see on the left hand side of the broader picture, we can see the traditional way of handling things like virtual machine, database on premises like MySQL, storage on tape drives. But as we gradually move towards the right hand side of the diagram, we can see the more of the fully managed serverless solution. Like if we take an example of the compute, we do have Fargate, Lambda. If we take an example of storage, AWS S3 is a really good example of the serverless storage. And the beauty is like AWS almost provides various serverless fully managed services in different domains like be it analytics, messaging, storage, database, and compute. Now, why serverless is like so popular and why it is so much agile? Because it basically enables the developer, customers, and builders to focus only on the business logic and API, and all the heavy lifting work like the compute, physical infrastructure, storage, database, message, orchestration, quick queuing, buffer, all will be taken care of by the AWS. Business just need to worry about the logic that they're going to return in any language, almost. Now, quickly move towards the next segment, that would be the data streaming. So, when we talk about the data streaming, there would be four main characteristics that we'll discuss, like the high volume, continuous, order incremental, and the low latency. So, streaming data is basically the data that is continuously generated by different sources, and such data should be processed incrementally using the stream processing techniques without having access to all the data. So there are various streaming use cases available, and also like industries using streaming data and streaming technologies to handle various use cases like the mobile apps data, web click stream data heavily used by the retail, or I would say the video on demand services, application logs data. So earlier in the earlier time, we used to store the logs firstly inside the server, then we'll dump it over to different kind of storage, and then we'll perform some kind of analytics if needed onto that. But nowadays, we are doing almost like near real-time data analytics onto the application logs that are being generated with the help of all the fully managed real-time services. IoT sensors and smart buildings are also the really great example of the streaming use case. Now we know like the various benefits and how we should adopt the real-time data streaming, but it's not easy. Like there are various challenges involved if we are going to deal with the real-time data, or I would say if we are going to uh, create or use any real-time data streaming services. Like it's not easy to it's quite difficult to set up. It's not scalability is gonna be an issue. We need to think about the high availability, and also it would be expensive to maintain if it's not a fully managed. So now the AWS Kinesis data stream comes into the picture because it is a fully managed services. It makes quite easy to collect, process, and analyze real-time streaming data that we can collect it from different resources, like the thousand of sources, and we can get the timely insights, and we can react quickly onto the new information that is being coming, and it enables users to process, analyze the data as it arrives, and respond quickly. Now, when in terms of the streaming data services with respect to the AWS, basically the Kinesis flavor, I would say there are typically four services: Kinesis video stream, data stream, Kinesis data firehose, and Kinesis data analytics. Video stream is something that we are not going to discuss in this particular session, but it deals with the incoming data that would be in terms of the video streaming data. Now coming on to the Kinesis data stream, it is scalable, durable, real-time data streaming services that can continuously capture like the gigabytes of data from hundred or thousand of different resources. Kinesis data firehouse is like quite easy to use. It's just capture, transform, and load the data from the Kinesis data stream to the different destinations like S3 or the Redshift. Kinesis Data Analytics is the service that basically caters about how we can apply the analytics using the SQL or Apache Flinks on the real-time data. Like we don't need to store the data to perform the analytics. We'll do the analytics using the Kinesis Data Analytics service onto the real-time streaming data. So how Kinesis works, or how the Kinesis enables the whole real-time data streaming pipeline. There would be the five main stages. First one would be the source, like which I mean the Source is something whichever is generating the data, be it the mobile device, IoT sensor, your web servers, which is having different kind of logs from the different kind of application clickstream. After that, we need something called as producer that will basically ingest the data into the Kinesis data streams. So this is called as producer, and we can use various we can use the AWS SDK written that is available in different languages to create the Kinesis producer, or we can use the Kinesis producer library to create a custom built solution for the producer task. We are going to use I've used the Kinesis producer library to create the producer task, and also AWS provides Amazon Kinesis agent that we can install in our web server, and it will basically watch a particular log location and stream it onto the Kinesis data stream. Now, when the data has been stored into the Kinesis data stream, now we need some kind of task that will basically consume that particular data and process that data. So those kind of tasks, we'll call it as a consumer task. We can use the Kinesis data analytics service also, fully managed service, and we can perform the analytics on the real-time streaming data, or we can use the Kinesis consumer library, and we can create our own custom solution where we can define how we are going to consume the data, how we are going to process the data, and ultimately where we are going to store that particular data onto a specific destination. Also, if we have a use case like we just need to get the data from the source, and ultimately we are going to store the data on a specific storage like S3, Redshift, or some searching storage like Elasticsearch or Splunk, then we can think of the Amazon Kinesis data Firehose. Now, how Kinesis basically stores the data? So Kinesis basically stores the data in the form of shards. So, or we would say like Kinesis data stream is a set of shard, and each shard has a sequence of data records. The shard is basically a uniquely identified sequence of data records in a stream. Its data retention is 24 hours by default, or it can go up to the 7 days. I think I'm not sure though, but AWS has recently launched, and they have increased the maximum limit up to 1 year. So it would be very beneficial to few of the enterprise customers that are basically looking for a solution where they can keep the data like up to more than the 7 days. And then once the data is inserted into the Kinesis, it is immutable. We can't delete the data. It is only going to expire after the duration that we have set onto the AWS console or while creating the Kinesis data stream. So we generally try to give the number of shards when we are creating the Kinesis data stream. Otherwise, there are few APIs that we can use, like be it the merge shard or the split shard at the runtime. But it would be like better if we can define the number of shards that we are going to use at the majority of the time at the start of while at the creation of the Kinesis data stream. Now, when we talk about the Kinesis consumer, there are typical two types of consumer, I would say, that we can think of. First one would be the standard consumer. Second one would be the enhanced fan out consumers. Standard consumer is where we have written like the consumer application. It will basically do the get records API to get the data from the shards, and there are few limits associated with the standard consumer like 2 MB per second per shard and 5 transactions per second per shard, cumulative of all the consumer that we operate on. Instead of that, on the other hand, we have the enhanced fan out consumer, where each consumer application get a dedicated 2 MB per second egress per shard. It basically register that particular consumer to a specific register that particular consumer to his shard, and it is a push model, unlikely of the pull model in the standard consumer. And every consumer application will get a dedicated 2 MB per second egress. So it is I think Initially, AWS launched a standard consumer, and in 2018 they launched an enhanced fan-out consumer. So nowadays, like mostly almost all the consumer are getting the benefit of the enhanced fan-out consumer if they have that kind of requirement where they need every consumer task to have a like are dedicated to MB per second egress condition, then they can use the enhanced fan out consumer. They can build the solution around that. Now the next segment would be like how we are going to write the Kinesis produce and consumer task or application, and we can deploy how we can deploy it using the serverless containers. So why containers? Because container, there are various benefits a container provides. First one would be the portability between the different platform. We can write it it doesn't matter like on which platform we are running the container. If we have built our images, if we have written the instruction, if we have built our images, we have stored be it in the Docker Hub or the Elastic Container Registry, we can use it on different platform, and it will be like it will act similarly on it doesn't matter like on which platform we are running, it will work exactly in the same manner. Also it provides basically improved security because it will be by the isolating application from host system and from each other also. And also definitely it provides the faster app startup, easy to scale, and also we can define like CPU utilization and the memory utilization components at the container level, and it will use like very less resources when we talk about in terms when we compare it with the VMs that are available right now. So for container, to deal with container, AWS has the AWS Container Services, and AWS Container Services it basically provides various benefits to the consumer. Like we don't it provides like if you need to have some kind of load balancer with respect to the containers, we can use the AWS Container Services. We can define the load balancer to the specific service that we will create, and inside the service we can define various containers. We can integrate the containers that we are launching using the CloudWatch metrics. We can define the auto scaling policy of those containers, and also we can define like how we are going to deploy the code inside all the containers. So AWS Container Services is really good and provides various benefits to its users. There are four main categories where AWS Container Service provides services. Like first one would be the registry. We can think of it on the same terms of the Docker Hub, where we'll store we'll store all the container images. Second one would be the orchestration. So we can choose either the Elastic Kubernetes services or the Amazon owned Elastic Container Services. And on the compute part, we can either choose the basic EC2 Elastic Compute Machine, or we can think of the Fargate, that is basically the serverless flavor of the container services. And in the networking side, we can integrate our container with the AWS Cloud Map and the App Mesh also. So the typical ACS service architecture example would be something like, okay, we have the load balancer, which is attached to the internet, and that users are basically hitting or basically providing the traffic to the load balancer. Then inside the EC2 instances, we do have various container tasks running. We do have various ECS agents installed inside in that particular EC2 instance that will basically connect the container task to the ECR service, to the ECS service, so that we can handle the auto scaling part. We can handle like how we are going to deploy all these images onto the specific containers. But now when we talk about in terms of if we need like seamless scaling, and if we don't need to worry about how we are going to manage all these compute machine, then we can think of the AWS Fargate. So AWS Forget is like we don't need to worry about any cluster infrastructure to manage. Everything will be handled at the container level. We basically just need to worry about the image or the code that we're going to build and the image that we're going to push onto the Elastic Container Registry or Docker Hub. We don't need to worry about how we are going to manage the resources, how we are going to manage the compute machine. We can just define the memory requirement and CPU requirement at the container level, and we can just say the AWS ECS or EK service to just launch the container task, and they will basically do all the management of these tasks. There are various benefits involved with the Fargate. We can bring our own Docker image, and we can utilize the tagging and cost allocation so functionality with respect to the Fargate. We can connect it with the various other services that AWS provide, be it the secret management, AWS parameter store, private link support. We can connect it with the VPC. We can use the VPC endpoint services to connect it with the various different services of the AWS. We can connect it to the Fargate with the AWS CloudWatch to collect all the logs. And also recently, like AWS has also started the Fargate Spot. Works almost on the similar front of the EC2 Spot instances. So it will help us in the cost reduction, like up to 50 or more than 50%. So how does basically a Fargate work? So we basically first of all, we need to define the task definition. Task definition is something where we'll define the CPU requirement, memory requirement, and inside the task definition, we do have the container definition where we will eventually define the container URL, be it the Docker Hub or be it the Elastic Container Registry ARN path. Basically, which particular container image we are going to run when we launch the Fargate server, when we launch the Fargate task. Then we need to define a ECS cluster. We'll say it is cluster, but it's kind of a placeholder, which will basically where we'll define all the services, tasks, deployment strategy, load balancers, scalability, auto scaling policy, and whatnot. Then we'll create the service. Service is something that will like suppose if we need a load balancer, the load balancer will be created only in the ECS service, not under the ECS task definition. And eventually we'll run those tasks using the when we basically create those tasks, we will run those tasks and we'll manage those tasks with the help of ECS service. So construct when we using the Fargate with Amazon ECS is like initially, as I explained, we need to create the task definition. It will be having the image, CPU, memory requirements, and then we'll run that particular task. So it will basically run that particular task definition. And while when we opt it to run, we can choose the launch type as a Fargate, or if we are not going to run it as a Fargate, we can also select the launch type as a EC2 instance. Then it would be like we need to manage that particular EC2 machine also, but in terms of Fargate, it would be the serverless. Now service, as I explained, service is something if we need to have the ELB, we need to create the service, we need to connect, we need to associate the ELB and the targets with respect to the service definition that we are going to build. And service, then after we create the service is basically maintained all the running copies of the task, integrate with the ELB, and it will do like it will basically all the scheduling of the task also will be managed by the service. Now, as we are moving towards the demo part, so I have created the CloudFormation script like cloud, as you know, cloud formation is the infrastructure as a code. So I have created two cloud formation template. In the first one that I'll quickly show you. In the first one, I am creating the Kinesis data stream, Elastic Container Registry, and the second one, I am basically deploying the producer and consumer task as a Fargate launch type onto a specific ECS service. Okay, yeah, great. So demo time. Let me share my screen once again. Okay, great. So these two are the cloud formation template that I have executed just before 1 hour. So we'll quickly see the Kinesis ECR images cloud formation template first. So what it will do, this is the cloud formation template. Yeah. So it will under the resource section in the cloud formation template, it is basically first creating the Elastic Container Registry, followed by it is creating the Kinesis data stream of the shard count of 1. Then I'm creating the Kinesis data Firehose, and inside the Firehose I am attaching it. I'm attaching the S3 as a destination. Then I'm creating a S3 bucket and provide this particular S3 bucket as the ARN of this particular S3 bucket in the S3 bucket destination under the data Firehose. Then I'm creating few delivery roles. I am role and policy that will help us to talk to the various services. And in the end, I am creating a code build project that will basically create the container ECR images using the code present in my GitHub repo. So I will share the GitHub repo part on GitHub repo URL also. This is the GitHub repo URL. So it is picking up the code from the my GitHub repo and building the Docker container images of the both producer and consumer task and pushing it onto the respective ECR Elastic Container Registry. So if you see now under the output section, you can see the consumer repository, producer repository, Kinesis Firehose, Kinesis Stream, code build project, Docker images. So if we quickly see the Kinesis Firehose, if I go into the data Firehose, yeah, I can see S3 destination. So this is the bucket that has also been created by the cloud formation, the same cloud formation template. Now, not this. Yeah, this is the Elastic Container Repository. So you can see the consumer repository. We do have the Docker container image inside it. Now I'll quickly show you the Kinesis Fargate pipeline. This is the cloud formation template for that. So here we are, I'm basically defining like what would be the maximum producer or maximum consumer task that we are going to have once we define the auto scaling policy. Then what would be the container scaling target? Basically the value of the target CPU utilization. I have in the template that I have executed, I have kept it like 20, so that will quickly increase the incoming traffic to see whether it is running, whether it is getting increased or not. The meanwhile, while doing that, I will quickly execute a locust job that will basically start creating the users, and so basically we need to generate some amount of traffic onto our Kinesis producing consumer task so that our auto scaling policy will get triggered. So locus is basically a performance or the load performance tool where we'll create a dummy user which will create, and it will basically request it will basically start requesting onto the defined host. So this particular host is basically the load balancer that has been created with this particular CloudFormation template. So I'll just execute this, so you can see it has started, the number of requests has started getting increased. Okay, coming back to the CloudFormation template. So under the resource, initially I'm creating the network related stuff like VPC, 2 public subnet, 2 private subnet, one for the producer, another one would be for the consumer. Then after that, yeah, I'm creating the ECR cluster, creating few of the IAM roles and policies. Then here, let's see, I am creating the ECS task producer definition. So remember the task definition where we need to define the CPU requirement parameter, memory parameter, and inside the task definition, we do have the container definition where also we'll define the CPU and memory requirement and also the container image URL. And this particular path is of the ECR repository that we have created from the first CloudFormation template. I'm providing the port mapping that on which the load balancer will listen. Also, this is the ECS service. We need the service to basically maintain the running copies of the task, and also because I need to create the load balancer. So under the ECS service only, I can associate the load balancer. I can't associate the load balancer with the task definition. So creating the target group also and associated it with the ECS service. Now if I come down, the same thing I have done for the consumer also. Consumer task definition, consumer service, but in the consumer service there would be no load balancer. I'm going to have a load balancer only from the producer side where we are going to accept the traffic. Consumer is something it will consume the traffic and process the traffic. So if we see the ECS cluster, there will be 2 services. If we go into the producer service, so see it is associated with the load balancer, the VPC details. Under the task, we do have a one running container Fargate container task. If I go inside it, open it, you can see the ECR image URL. This is the ECR. Kinesis data producer, environment variables, ports, and the AWS log configuration. Now if I come back, similarly for the consumer also, there would be no load balancer, but running task, there is one running task for that. Now if we quickly see the Kinesis producer, so See, this is the Kinesis producer task that we have written in Java, and we are basically adding the user record into a specific stream that we have created onto a specific stream key and with the data that we have defined. And while doing the consumer at the consumer end, I have used the Kinesis consumer library, and I am basically processing the records. I'm just like basically logging out that particular record into the CloudWatch so that we can verify like whether we are getting the data is getting generated or data is getting stored or getting stored at the consumer side, or it has been reached up to the consumer side or not. And then we are doing the processing of record. It's a basic quite basic implementation using the Kinesis consumer library and producer library. The idea is to show you like, okay, we are sending the data from the source side, and then through the load balancer data is coming onto the producer task. Producer is basically sending the data to the Kinesis data stream, and at the consumer side, we are getting the data. We can see the data into the CloudWatch logs, and also we do have a Kinesis data Firehose that will basically dump the data onto the S3 bucket. So I will. This is my Linux node. I'll please run one sample file to ingest some amount of data. So if we see the output section of the second CloudFormation template, we can find the dashboard and also the endpoint. This endpoint is of the ALB. I have created like the sample data record of like AWS community day. This is a sample record. Now if I go onto the Kinesis destination, also if I go into the CloudWatch log of the consumer stream, we return here like community. It must be coming in a while. Now, if you quickly see the dashboard, like this particular dashboard. Let's see. Initially, it was only a one task running onto the producer. Now it has been increased up to the two tasks because of the increased CPU utilization. So the alarm or the auto scaling policy will act on whenever we do have a three data point onto the above CPU utilization of the 20%. So now it's been running onto the 30 or 40% or getting increased. So that is why the auto scaling policy has been triggered, and it has started another producer task. Similarly, if I go onto the S3 bucket, it's just So I just entered one sample record, so I'm able to get that onto the S3 bucket. Now, if I come back to the where is the ECS service? Yeah, here. If I come back on to see the number of tasks, so see now there are 4 running tasks of the producer Fargate and 2 are the consumer Fargate. Same, it will get updated onto the dashboard. So now coming back to onto the presentation. Yeah, so the idea was to show you guys like how we can create the producer task using the Kinesis producer library, and we can run it under the Fargate. Similarly, how we can create the consumer task using the Kinesis consumer library and run it into the Fargate in a serverless manner, and how we are going to utilize the Kinesis data stream to enable the real-time data streaming solution. And all these consumer producer tasks will act on the auto scaling policy based on the CPU utilization metric that we have defined. So in the end, there are a few new trends that are happening in the world of containers and serverless real-time data pipeline, like AWS ECS recently announced the AWS Copilot, a new CLI tool to deploy and operate containers in AWS. CloudWatch has also now monitors the Prometheus metrics from container environment. Now AWS EKS on Fargate has also been launched, and we do have a support of EFS. And AWS has already launched Fargate Spot back in 2019, like the last year in December. They have launched that, so that now customer can utilize the benefit of Fargate Spot, and they are able to reduce their total cost up to 70%. So yeah, that was all, folks. So I hope you have found this session and the demo useful, and maybe it will help in your journey if you are building the serverless solution, be it the real-time data streaming solution or be it the container Fargate serverless solution. So thank you all. I would think now we can open for a few questions. Thank you so much.